Hi Andy. Now we will discuss third question paper from electrochemistry based on Nernst equation. We know that Nernst equation is very important for various competitive exams, right? So we'll see some questions from Nernst equation. First one, standard reduction potential of zinc is minus 0.76 volts. What is the potential of electrode in 0.01 molar zinc sulfate solution at 25 degrees centigrade? Okay, so here whether we have to calculate reduction potential or oxidation potential is not mentioned. If it is not mentioned, generally we may calculate what reduction potential. And according to IUPAC convention, electrode potentials are said to be what reduction potentials. And if they specially mentioned to calculate oxidation potential, then you may calculate oxidation potential. Otherwise, if they mention generally potential of electrode, then you calculate reduction potential. And right. Here standard reduction potential is given E0 Zn plus 2 to Zn. Standard reduction potential of zinc is given minus 0.76 volts. Next concentration given 0.01 molar. That means we can write as 10 power minus 2 m. Okay. And we want to calculate reduction potential. And so if you write the reduction reaction Zn plus 2 plus 2 electrons gives rise to Zn. Now apply Nernst equation. And so Nernst equation gives how electrode potential changes with the concentration of electrolyte. Here at 0.01 m concentration, we want to calculate electrode potential. And so how electrode potential changes with concentration, that is given by Nernst equation. So what is Nernst equation? We have E is equal to E naught minus 0.059 by N log Q. Q is called reaction coefficient, N is the number of moles of electrons involved. If you substitute it, E is equal to E0. Here we are calculating reduction potential. So here also we have to substitute what? Standard reduction potential. If they have given standard oxidation potential, then we have to change the sign. And they have given standard oxidation potential plus 0.76, then standard reduction potential is what? Minus 0.76. So minus 0.76 minus 0.09, nearly we can write as 0.059, we can write as 0.06. Number of moles of electrons involved is 2 log product side. Is there any ions or no ion? No ion. 1 by reactant side we have ion. Concentration of Zn plus 2 is given 10 power minus 2. And if gases are involved, we have to express their concentration by using pressure. And for example, 1 atmosphere, 2 atmosphere, like that pressure may be given, that we have to substitute it. So this is 0.03. So minus 0.76 minus 0.03. If you bring this to numerator, log 10 power plus 2. Log 10 power n is n. So minus 0.76 minus 0.06. That means nearly we are getting minus 0.82. Sorry. Nearly we may get minus 0.82 volts. And that is option A is correct. Okay. Otherwise, you can directly use this formula also. And in general, you may remember this formula to calculate reduction potential. And so the formula to calculate reduction potential is E is equal to E naught plus 0.059 by N log C. And okay, E is equal to E naught plus 0.059 by N log C. That is the general expression. You may remember E naught given minus 0.76. Here if you are calculating reduction potential, here also we have to substitute reduction potential. Here we are calculating reduction potential, here we have to substitute standard reduction potential. Here we are calculating oxidation potential, here we have to substitute standard oxidation potential. Otherwise, if they ask you to calculate oxidation potential, first you calculate reduction potential like this. Simply you change the sign, and finally if you change the sign, you will get oxidation potential. So oxidation potential of zinc at 0.01 m concentration is what? Plus 0.82 volts. Right now plus 0.06 by 2 log 10 power minus 2 concentration. So minus 0.76 plus 0.03 into log 10 power n is n. So we will get what? Minus 0.82 volts nearly. Okay. If you take 0.059 exactly, you may get 0.819. Next one. So previously we calculated electrode potential. Now it is given what? Cell potential. Okay, this double vertical line indicates what? Salt bridge. And last time one of the competitive exams This question given and directly. Double vertical line gives salt bridge. This single vertical line represent what? Phase boundary exists between electrode and electrolyte solution. Phase boundary that exists between electrode and electrolyte solution. Okay, now we know that left side of salt bridge we have for anode representation, and right side of salt bridge we have what? Cathode representation. So here what is anode and what is cathode? And iron electrode is anode, copper electrode is cathode. What is the potential that we have to calculate? Standard cell potential is given as 0.7988 volts. And standard cell potential means what? That is the potential measured at 25 degrees centigrade and temperature of 25 degrees centigrade and for 1 mole. Okay, this is volt and is 0.788 volts not given. Okay, and now what is the formula? First you write the reaction at anode and oxidation reaction, that is Fe gives rise to Fe plus 2 electrons. Now if you write the reduction reaction at cathode, that is copper plus 2 electrons gives rise to copper. Now cell reaction, that is iron plus copper plus 2 gives rise to iron plus 2 plus copper. This is the cell reaction. So we wrote oxidation of reaction at anode, reduction of reaction at cathode. Next, if you add those two, you will get cell reaction. Always we have to balance the number of electrons. Okay. Now apply Nernst equation. What is the Nernst equation? E is equal to E naught minus 0.059 by N log Q. So if you apply to cell reaction, E cell is equal to E0 cell minus 0.059 by N log Q. So that is equal to E0 cell, that is given 0.788 volts minus 0.06. I am writing for the simplicity. Number of moles of electrons involved is 2. Log Q. Q means product side ion concentration by reactant side ion concentration. Product side we have iron plus 2. Reactant side copper plus 2 we have iron plus 2 concentration 0.1. We can write as 10 power minus 1 by concentration of copper plus 2, that is given as 0.01. That means 10 power minus 2. So 0.788 minus 0.03. If you bring this to numerator, 10 power minus 2 becomes 10 power plus 2. 2 minus 1, 10. Log 10 value is 1. So nearly we are getting 78 minus 03. So 758. Right, nearly we are doing some rough calculation. 0.758 volts we are getting. That is option D is correct. Okay. Okay, here E0 cell minus 0.059 by N log. Product side we have concentration of Fe plus 2 and reactant side we have what? Concentration of copper plus 2. So without writing all these electrode reactions and directly you put this one by this one and always we will get this one by this one and Q, right? Fe plus 2 by copper plus 2 and. But for example here Ag plus Ag is given and for example here charge is 2 units and here charge is 1 unit. So Fe plus 2 by Ag plus power 2 also. Concentration of Ag plus power 2 we will get. Like that you can write directly. Okay, some practice is required. So we can write directly. Next one, standard reaction potential of zinc and copper given. The cell reaction is whether it is spontaneous or not. Okay, or at equilibrium. So we know that from delta G is equal to minus NF E cell. Okay, if E cell is positive, delta G we get negative spontaneous. If delta E cell is negative, we get delta G positive non-spontaneous. If E cell is 0, delta G we get 0, then such process is said to be under equilibrium, right? So we have to calculate what? E cell we have to calculate and we have to verify whether we are getting positive, negative or 0. So E cell is nothing but what? Here what are given and the reduction potentials are given. So cathode reduction potential minus anode reduction potentials. Cathode reduction potential minus anode reduction potential. If oxidation potentials are given, you simply change the sign and to get reduction potentials, right? So cathode reduction potential. What is cathode here? Here zinc undergoing what? Reduction. So that means that is cathode. Copper is undergoing what? Oxidation. So anode. So according to the cell reaction given, copper is anode undergoing oxidation, zinc is undergoing reduction, so it is cathode. So cathode reduction potential. What is cathode and here? Zinc. What is the reduction potential of zinc given? Minus 0.76. Minus of what is anode and copper is anode undergoing oxidation. What is the oxidation potential of copper given? Minus 0.34. That means we are getting minus 1.1 volts nearly. So we get a negative only. Negative means delta G what? Positive. That means whether cell reaction is spontaneous or non-spontaneous. Non-spontaneous. So option B is correct. Okay. Reverse given and actually copper undergoes reduction, zinc undergoes oxidation, but reverse given, that's why it is non-spontaneous. Next one, standard reduction potential of zinc and silver are given. Silver and zinc are given. Which of the following is true? Silver reacts with 1mH2SO4, but zinc doesn't. Silver reacts with 1mH2SO4, but zinc doesn't. So if you place zinc and silver rod, and okay, we are taking silver rod in H2SO4. What happens if you see? Silver reacts with 1mH2SO4 on it. For example, if silver goes into the solution as Ag plus electron, then whatever H plus ions we have in the solution, H plus electron, we may get half H2. This reaction may occur. Okay, if silver undergoes oxidation, then H plus ion may undergo reduction. Like this we may expect, but actually this cannot happen, since what is the standard reduction potential of silver given? Okay, silver given, silver and hydrogen if you compare, silver and hydrogen if you compare, silver is plus 0.80, standard hydrogen electrode potential is 0. These are the reduction potentials given. These are the reduction potentials given. Whose reduction potential is more? Silver reduction potential is more compared to hydrogen. So silver undergoes what? Reduction. Hydrogen undergoes what? Oxidation. Silver undergoes reduction. Hydrogen undergoes oxidation. But here silver undergoes reduction means what? Reverse reaction. Ag plus electrons gives rise to Ag. But is there Ag plus ions or silver? Silver. Okay, Ag plus ions are not there, silver we have. So that means reverse reaction is possible, but this reaction is not possible. That means silver cannot react with H2SO4 and silver cannot produce hydrogen gas with acid, and silver cannot produce hydrogen gas with acid. Okay, what about zinc and zinc? If you compare zinc and hydrogen gas, what about the reduction potential of zinc given? And minus 0.76. What about hydrogen electrode potential? 0. So that means hydrogen electrode potential is more. That means zinc undergoes what? Oxidation. Okay, the tendency to participate in the reduction is more for what? Hydrogen electrode. So hydrogen electrode participates in the reduction. So zinc acts as what? Anode. Hydrogen electrode acts as what? Cathode. That means what is the reaction occurs? What is the actual reaction may occur? So zinc undergoes oxidation. So zinc gives rise to Zn plus 2 electrons. Okay, whatever the electrons are released, those are taken by hydrogen ions. 2H plus 2 electrons gives rise to H2. Okay, so that means zinc produce hydrogen gas and with acids. Zinc electrode produce or evolve hydrogen gas with acids, H2SO4 acid. You may take hydrochloric acid, same we will get, right? But what is given? And Ag reacts with 1mH2SO4, but zinc doesn't given. But zinc can react or not? Yes. Zinc, when you place zinc electrode in silver sulfuric acid, zinc undergoes oxidation and hydrogen ions undergoes reduction. That is possible or not? Yes, that is possible. So second option correct. And zinc reacts with 1mH2SO4, but silver doesn't. So option B is correct. So like this, you have to verify based on what? Their reduction potentials. Okay. Based on the reduction potential of zinc and hydrogen, zinc has to participate in the oxidation and hydrogen participate in the reduction. So this is possible. But silver and hydrogen, if you take, silver undergoes reduction. Silver undergoes reduction means, but Ag plus ions are available or not? Not available. We are taking what? Silver electrode in H2SO4. How Ag plus ions are available? And not available. So Ag plus cannot undergo reduction. Okay, that is not possible. Okay. Next one, a hypothetical electrochemical cell is shown below. Okay. What about cell reaction? Direct question. What is the reaction at anode? And this is anode. So reaction at anode is A gives rise to A plus plus electrons. Right. What is the reaction at cathode? And that is B plus plus electrons gives rise to B. So what is the net reaction? Always electrons to be matched and balanced. And so A plus plus B plus gives rise to A plus plus B. Direct question. So this is the cell reaction. So that is option A is correct. Next, this is somewhat typical question. And copper plus is unstable in solution and undergoes simultaneous oxidation and reduction. Simultaneous oxidation and reduction is called what? Disproportionation. Right, according to the reaction. See here, simultaneously copper is undergoing oxidation as well as reduction. Here, if you see here, oxidation number is increasing, and so this is oxidation, and copper plus to copper, and so oxidation number is decreasing, and so this is what? Reduction, and okay. Copper plus 2 to copper 2 plus is oxidation. Copper plus 2 to copper solid is reduction. Choose the correct E naught for the above reaction. We have to calculate E0 for the above reaction. Okay, so once again, if you see 2 copper plus is equal to, or gives copper plus 2 plus copper, and this is what? Oxidation. So this is cathode, and this is what? Reduction, and so this is, sorry, reduction occurs at cathode. Reduction occurs at cathode, right? So this is cathode, and here oxidation, and oxidation, so it acts as anode. So now we have to calculate E0 cell. E0 cell is equal to what? E0 cathode reduction potential minus E0 anode reduction potentials, and both we have to substitute what? Reduction potentials. So what is cathode? And here copper plus 2 to copper, that is cathode. So E0 copper plus 2 to copper, and minus reduction potential of anode. Okay, this is the anode couple, and copper plus is changing to copper plus 2. Copper plus is changing to copper plus 2, but here we have to take what? Reduction potentials, and that is reduction potential of anode, and reduction potential of anode, that is copper plus 2 to copper plus, and copper plus 2 to copper plus. Okay, and we have to take reduction potentials only, and right, copper plus 2 to copper plus is given, and copper plus 2 to copper plus is given, that is 0.15. This is given 0.15, but copper plus 2 copper plus 2 copper not given. Copper 2 plus 2 to copper is given, so this is not given, and so first we have to calculate this one, and first we have to calculate this one. So for that, I told you, if two off electrode reactions are given, how to calculate third off electrode reaction, and so here you see, we need what? Copper plus 2 to copper, and copper plus we want to get left side, and so copper we want to get right side, and here copper is on right side only, no problem, but here copper plus is right side, but we have to get left side, and so that you take reverse, and so this is what? E0 copper plus 2 to copper is given 0.34 volts. Next, E0 copper plus 2 copper plus 2, that is equal to what? Minus 0.15 volts. Here it is given reduction potential, but I took oxidation potentiality, so minus 0.15 volts. Now if you add these two, what we get? And if you add these two, copper plus 2 gets cancelled, right? Now what we get? Copper plus 2 to copper plus 2 to copper. Okay, so if we are adding 1 and 2, we are getting third reaction, our required reaction. Okay, what we get? And E0 left side, what we get? Copper plus, right side will get copper, and so what is the formula? And if E1 naught E2 naught is given, how to get E3 naught? The formula is E3 naught is equal to N1 E1 naught plus N2 E2 naught by N3, and so formula is E3 naught is equal to N1 E1 naught plus N2 E2 naught by N3. So now substitute the data, and N1 in the first reaction, how many electrons are involved? And plus 2 to 0, 2 electrons, and 2 into 0.34, 0.68. In the second one, and plus 1 to plus 2, and how many electrons are involved? Only one electron is involved, so minus 0.15. by N3 and third electrode reaction. Copper plus 2 to copper. How many electrons are involved? Plus 1 to 0. So only one electron is involved. 1. So that means we are getting what? 0.53 and so this we got 0.53 and finally. So if you substitute there 0.53 minus 0.15. Okay, we'll get 0.38 volts and that's 0.38 volts. That is option C and D. Okay, and reduction potential of cathode minus reduction potential of anode, but reduction potential of cathode is not given directly, and so based on the data given, we calculated first of all reduction potential of cathode and then we substituted here. Okay. Next one, in a galvanic cell consisting of zinc electrode and copper electrode, galvanic cell is mentioned. And so galvanic cell means what happens in galvanic cells? Chemical energy converted to electrical energy. If you take galvanic or voltaic cells, if you take electrolytic cell, electrolytic cell. In electrolytic cell, which procedure we carry out? And electrolysis we carry out. In electrolysis, electrical energy converted to chemical energy. And this is spontaneous and here this is non-spontaneous. Since without supplying electrical energy, this cannot occur. So this is delta G positive, E negative, and here delta G is negative, E positive, and delta G negative, E positive. Here delta G positive means E negative. Okay, Randy. So here spontaneous chemical reactions occurs, electrical energy will be produced. But here chemical reactions cannot occur spontaneously. By passing electrical energy only chemical reactions occur. So therefore this is non-spontaneous, delta G positive. For this delta G is negative. So in galvanic cells what happens? Chemical energy is converted to electrical energy. Zinc acts as anode, copper electrode acts as cathode. This is a famous example, that is nothing but what? Daniell cell. Okay. Daniell cell is constructed by using what? Zinc and copper electrodes. Transport number determines what? Transport number or transference number or hit-off numbers. That determines what? Fraction of the total current carried by each ion. So total current carried by solution electrolyte. Total current carried by an electrolyte solution. Total current means current carried by cation and anion. For example, 100 units. In that current carried by cation is 75 units. Current carried by anion is remaining, that is 25 units. So what is the transport number of cation and 75 by 100? So 0.75. What is the transport number of anion? 0.25. Always sum of the transport numbers of cation and anion is equal to how much? 1. Cation also indicated as T plus, anion is also indicated as T minus N. Okay. So transport number is nothing but what? Fraction of the total current carried by anion in the total current. A plus B gives C plus D, Kc is equal to K1, equilibrium constant for first reaction given K1, electrode potential A volts. Next one, next this is multiplied with 2 and this is multiplied with 2, equilibrium constant is given as K2 and electrode potential is given as B volts. Then what is the relation between A and B and what is the relation between K1 and K2? So we know that electrode potential or cell potential, electrode potential or cell potential is intensive property or extensive property. Intensive property doesn't depend on amount. So you may take 1 mole or 2 moles. Okay, and this reaction if you observe, if you multiply with 2, you will get this reaction. So you may take 1 mole or 2 moles. Cell potential or electrode potential doesn't change. And that means A is equal to B we will get it. So we will get what? In both the cases same potential will get A is equal to B and so A is equal to B is given in option A and D and E. So B and C are not correct and if you multiply with the 2 and then what we will get equilibrium constant for first reaction is what? Product side concentrations by reactant side concentrations. Okay, K1. And what about K2 and product side concentrations, that is C square into D square by corresponding number of moles, stoichiometric coefficients I am writing on P square. So this is nothing but what? CD by AB whole square. That means K2 is nothing but what? K1 square. K2 is nothing but what? K1 square. That is option A is correct. Okay. So the general expression is if reaction 2 is equal to N into reaction 1, then K2 is equal to what? K1 power N. And if reaction 2 is equal to what? N into reaction 1, K2 is equal to what? K1 power N. And so that is option A is correct. Here we are multiplying with the 2 and so in the place of N we will get 2. Next, given AG0, AG plus AG, okay, silver reduction potential is given, magnesium standard reduction potential also given, and copper also given. Next to mercury, okay, all these four electrode potentials given and standard electrode potentials and reduction potentials, and in each case see oxidation number is decreasing, so reduction potentials. Which of the following statements is correct? Silver nitrate can be stored in copper vessel. Silver comma copper, if you verify, and silver comma copper, if you verify, same similar to a previous question, one of the questions we discussed, similar to that. Silver comma copper, if you verify. What about reduction potentials? And silver given 0.80, copper given 0.34 volts. So silver reduction potential is more compared to copper. So that means silver acts as what? Cathode. Copper acts as anode. Silver undergoes what? Reduction. Copper undergoes oxidation. Okay, so silver nitrate can be stored in copper vessel. Okay, can we store or we cannot store, and we cannot store since silver undergoes what? Reduction. This is the reaction occurs. Here Ag plus ions are available or not? Yes, Ag plus ions are available. So Ag plus plus electron gives Ag. Silver undergoes reduction. Copper undergoes what? Oxidation. So copper vessel gets deteriorated and copper vessel can be dissolved, and if you store silver nitrate in copper vessel, what happens? Copper can be dissolved. Copper goes into the solution as copper plus ions, and whatever the Ag plus ions available in the electrolyte solution, those will be deposited as silver. And that means what happens? And we cannot store, and okay, if you store, what happens? Copper will be dissolved, and so we cannot store. Next, copper and magnesium. If you take copper, whether copper can be stored in magnesium vessel or not, copper nitrate CuNO3 taken twice, and okay, whether copper can be stored in magnesium vessel or not. Copper and magnesium, if you compare it. What about copper given plus 0.34, magnesium minus 2.37, and okay, magnesium given minus 2.37, and so copper reduction potential is more. So copper undergoes what? Reduction. So it acts as cathode, and it undergoes reduction. So it acts as cathode. So what about magnesium? And undergoes oxidation. It acts as anode. And okay, if copper nitrate can be, if you store in magnesium vessel, what happens? And copper undergoes reduction. So whatever the copper present in the solution, that undergoes reduction, and magnesium undergoes what? Oxidation. Again, magnesium can be dissolved, and magnesium is dissolved. Magnesium undergoes what? Oxidation, and whatever the copper plus ions present in the solution, those can be deposited or undergoes reduction. So therefore, we cannot store copper nitrate in magnesium vessel. Next, what about copper? All the remaining, all are correct, is not possible. So therefore, copper chloride, cupric chloride can be stored in silver vessel. So now if you compare copper and silver, once again 0.34, this is 0.80. Okay, this is not possible means silver nitrate we cannot store in copper vessel, means copper chloride we can store in silver vessel. Okay, reduction potentials, right? This is oxidation, anode. This undergoes reduction, cathode. So reduction means what? Ag plus plus electrons gives rise to Ag. But here, whether Ag plus ions are available or not available? Not available. Ag plus ions are not available. So this, whether this reaction can occur or cannot occur? Cannot occur. Copper undergoes oxidation. But here we are taking copper vessel or cupric chloride electrolyte. And electrolyte we are taking. We are not taking copper vessel. If you take copper vessel, this reaction may occur. Right? We are not taking copper vessel. So these reactions cannot occur. So we can store cupric chloride in silver vessel. Okay. Next one. The standard electrode potential is given, and the standard EMF of the spontaneous cell set with these electrodes is, okay, E cell is equal to what? E cathode minus E anode. Okay, we have to follow what? Reduction potentials. Okay, okay. Next, what is the question? And spontaneous cell. The cell, we have to construct cell such that it has to undergo chemical reactions spontaneously. And when spontaneous chemical reactions occur, if E cell is positive, when E cell positive, and cathode reduction potential must be greater than anode reduction potential. So here, whose value is bigger? 0.76, 0.44, and 0.76 is large. So it acts as cathode, and so iron acts as, sorry, zinc acts as cathode, and iron acts as what? Anode. 0.76 volts given, and so 0.76 minus 0.44, and so 0.32 positive we got, and so that means delta G negative, and so whatever you may do, and you have to get positive value. You have to get positive value. So 0.32 volts. Option D is correct. Okay. A gas X at 1 atmosphere is bubbled through a solution containing a mixture of Y and Z at 25 degrees centigrade. If the reduction potentials of Z is greater than Y is greater than X, then what happens? Z is greater than reduction potentials, and Z is greater than Y is greater than X given. And now Y will oxidize X and not Z. Y will oxidize X but not Z, like that given. And Y and X, if you compare, first of all, Y and X, if you compare, Y comma X, Y reduction potential is more compared to X. Okay, so Y undergoes what? Reduction. Okay, X undergoes what? Oxidation. Okay, Y undergoes reduction means it acts as what? Oxidizing agent. Okay, Y acts as oxidizing agent. X itself undergoes oxidation means it reduces another substance. So it acts as reducing agent. Okay, now what is the question? Y will be oxidized X. Y will be oxidized X. Y will be oxidized by X, maybe. Y will be oxidized X. Y will oxidize and B also Y will oxidize X and not Z. Okay, whether Y will oxidize X or not, yes, it is an oxidizing agent. Y is an oxidizing agent, itself participates in the reduction, so it can oxidize X, right? It can oxidize X and right. Next, Y will not oxidize Z and see Y and Z, if you compare Y and Z, Z is greater than Y is given. Z is greater than Y is given. So Z undergoes what? Reduction, right? That means it acts as oxidizing agent. Y undergoes what? Oxidation. So it acts as reducing agent. So Z is the oxidizing agent, and so Z will oxidize Y. Z will oxidize Y, and but what is given? Y will oxidize Z another. Y, sorry. Otherwise, it is given Y cannot oxidize Z. So Y is what? Oxidizing agent or reducing agent? Reducing agent. So Y will reduce Z. So Y cannot oxidize Z. Y will what? Reduce Z, but Y cannot oxidize Z. Okay. So Y will not oxidize Z. So that is correct statement. Okay. Simply like this, you have to compare it. So the one which participates in the reduction will act as oxidizing agent. The electrode which will participate in the oxidation will act as reducing agent. That means Y will reduce Z or Z will oxidize Y, and Y will reduce Z or Z will oxidize Y. Okay, Y will reduce Z. That means Y cannot oxidize Z. Okay. Next one, the cell voltage of Daniel's cell given 1.07 volts. If the reduction potential of copper cathode is given and reduction potential of anode zinc, we have to calculate. This is what? Anode, and this is cathode. Cell potential is given and volts, and reduction potential of cathode is given. What is the reduction potential of anode? And so we know that E cell is equal to E cathode minus E anode reduction potentials. E cell given in this case 1.07 volts. Cathode is what? Copper. Copper potential is given 0.34. Anode, that is zinc. zinc potential we want to calculate. And if you bring this zinc left side, E Zn plus 2 Zn, that is equal to 0.34 minus 1.07. If you do nearly, we will get minus 0.73 volts. Minus 0.73 volts, option D. Next one, the standard electrode potential for the following reaction is E0 is given, and E0 standard electrode potential is given 1.33 volts. Okay, what is the potential at pH is equal to, what is the potential at pH is equal to 2.0, and pH 2.0 means here H plus ions are there. What about concentration of H plus, and 10 power minus pH? What is the concentration of H plus? We have 10 power minus pH. Our pH is equal to minus log concentration of H plus. So 10 power minus pH means 10 power minus 2 m. That is the concentration of H plus ions given, and right, we have to calculate electrode potential. So how electrode potential changes with concentration, that is given by Nernst equation. Apply Nernst equation. E is equal to E naught minus 0.06 by n log Q. So E naught is given 1.33 minus 0.06 by number of moles of electrons involved in the electrode reaction, that is 6 log Q. Product side ions, copper plus 3 we have, but its concentration is given 1. So 1 power 2, 2 moles of copper plus 2 is there, copper plus 3 is there. Reactant side also, copper Cr2O7 2 minus ion we have, but its concentration also given 1. So 1 into H plus ions are there. What is about the concentration of H plus ions? 10 power minus 2. 10 power minus 2 whole power 14. 10 power minus 2 whole power 14. 14 twos are 28. So 10 power minus 28 we are getting. So therefore 1.33 minus 0.01. 1.33 minus 0.01. If you bring this to numerator, 10 power minus 28 becomes 10 power plus 28. Log 10 power n is n. Log 10 power 28 is 28. So 1.33 minus 0.28. That means nearly we will get 1.05 volts. 1.05 volts, option D. Okay. Instead of taking 0.059, we are taking 0.06. Okay. Slightly rough calculation we are doing. Okay, and a simple substitution only in the Nernst equation. Okay, the pH instead of giving H plus ion concentration, pH is given, and from pH we can get H plus ion concentration like this. Next one, the standard reduction potential of cadmium is given. What is the value of pH? What is the value of pH at cadmium plus 2 concentration 1 m and pressure of H2 is given 1 bar, above which reduction of copper plus 2 by hydrogen to cadmium metal will be spontaneous. Reduction reaction, we have to take which reaction? Reduction of cadmium plus 2, reduction of cadmium plus 2 by hydrogen to cadmium we want to get. So cadmium undergoes reduction, that means hydrogen undergoes oxidation, and okay. Right, when it will be spontaneous, at which pH this reaction will be spontaneous? What is the value of pH for this reaction to occur spontaneously? And okay, now pH indirectly concentration, and we have to see the relation between concentration and cell potential. And E cell we have to get positive, and E cell we have to get what? Positive. Then delta G negative spontaneous. So we have to get E cell positive, and when we get E cell positive, and here E cell is equal to what? E0 cell according to Nernst equation minus 0.059 or 0.06 by n log Q, right? So E0 cell, and E0 cell means E0 cathode minus E0 anode, reduction potentials. What is the cathode here? Cadmium plus 2 undergoing reduction, so that is cathode. Hydrogen undergoing what? Oxidation, so that is anode. Okay. So what is the reduction potential of cadmium given? Minus 0.40. Minus 0.40. What is standard hydrogen electrode potential? 0. So that means minus 0.40. That is minus 0.40. That if you substitute here, minus 0.40 minus 0.06 by number of electrons involved, how many? And cadmium plus 2 electrons gives rise to cadmium. H2 gives rise to what? 2H plus 2 electrons. And So 2. Log Q. Product side we have H plus ions. So H plus power 2, right? H plus power 2. By hydrogen gas we have, if gases are there, we have to express their concentration with respect to pressure. What is the pressure given? And 1 bar. So 1 and how many moles is there? 1 mole only. 1 power 1 and okay. So here we are getting 0.03. 0.03. So E cell is equal to what? Minus 0.40 minus 0.03. Here plus I am writing and minus sorry 2. 2 will get at the beginning and log h plus power log m power n we can write as n log m, that 2 we can write at the beginning 0.03 into 2 0.06 minus log h plus we can write as pH and so 0.06 pH and now for which value of pH we get E cell positive and that is the question. We have to get E cell positive, delta G negative. Okay. If you substitute to 0 and if you substitute to 0 pH value, so minus negative value we are getting it. If you substitute 2 and 2 means 0.12, minus 0.40, 0.12, no, 4.24 and minus 0.40 minus plus 0.24 we are not getting and okay. Next one 6 and minus 0.40 plus 0.06 into 6 0.36 0. minus 0.40 plus 0.36 కొంచెం క్లోజ్గా వచ్చిందండి కాబట్టి ఇది కూడా ఎగ్జాక్ట్ కాదు. అబౌవ్ 6 we will get అండి. ఇక్కడ క్వశ్చన్ వాట్ ఈస్ ద వాల్యూ ఆఫ్ అబౌవ్ pH అని ఉంటే ఇంకా కరెక్ట్గా ఉండేది. ఓకే, అబౌవ్ 6 వీఆర్ గెటింగ్ నెగటివ్ వాల్యూ అండి. అబౌవ్ 6 ఓకే, కొంచెం దగ్గరకు వచ్చిందండి. ఇవైతే ఇంకా చాలా దూరంగా ఉన్నాయి. 0 అంటే మైనస్ 0.40, 2 అంటే ఎంత వస్తుందండి 0.12 అంటే మైనస్ 0.28, 6 సబ్స్టిట్యూట్ చేస్తే ఎంత వస్తుందండి మైనస్ 0.4 వస్తుంది, మైనస్ 0.04 రైట్. సో కొంచెం క్లోజ్గా వచ్చిందండి. ఇంకా అబౌవ్ 6 తీసుకుంటే మనకి యూ విల్ గెట్ డెల్టా జీ సారీ ఈ సెల్ పాజిటివ్, డెల్టా జీ నెగటివ్, స్పాంటేనియస్ అండి. సో ఫ్రమ్ ద ఆప్షన్స్ అబౌవ్ 6 we make it అండి. Next, in the previous type of question only again, already we discussed 2 questions of this type. Silver reduction potential given, zinc reduction potential is given. Which of the following is correct? And silver and hydrogen, if you verify, and silver and hydrogen, if you verify reduction potentials, silver is 0.80, hydrogen is 0, so greater than. So it undergoes what? Reduction. It acts as cathode. Hydrogen undergoes what? Oxidation. So it acts as anode. So this is the reaction occurs. Reduction means Ag plus electron gives rise to Ag. So which reaction is feasible, possible, that we are verifying it. Which reaction is feasible, that we are verifying it. Now this reaction is possible here or not, that we have to verify again. Okay. First, based on the values given, which reaction is feasible, that we are checking it. Next one, hydrogen undergoes what? Oxidation. So H2 gives rise to 2H plus 2 electrons, right? So here what is given? Ag plus can be reduced by H2. Is it correct or not? H2 undergoing oxidation means it is reducing agent or not? Reducing agent. That means silver can be reduced by hydrogen, right? Ag plus can be reduced by hydrogen. That is correct one. And hydrogen undergoing oxidation means itself acts as reducing agent. That means it can reduce Ag plus ions to Ag. And it can reduce Ag plus ions to Ag. Or we can say that like this only. Ag plus can acts as what? Oxidizing agent, right? So we can say like this only. Ag plus can oxidize. Ag plus can oxidize H2. We can say like this only. Or H2 is undergoing oxidation and that means it acts as reducing agent. So H2 can reduce Ag plus ions. Okay, both are correct. And Ag plus can oxidize H2, right? H2 is oxidized by Ag plus ions, or H2 can reduce Ag plus and or Ag plus can be reduced by H2. Both are correct. Okay. Whether Ag can oxidize and H2 to H plus, no. Whether Ag is oxidizing agent oxidizing agent. Silver is oxidizing agent. So silver can oxidize. Right. What is the mistaken here? Silver can oxidize or Ag plus can oxidize. Ag plus can oxidize H2. Okay, silver itself participates in the reduction and silver its Ag plus itself participates in the reduction and hydrogen undergoes oxidation. So that is the wrong and see small mistake and Ag plus can oxidize and Ag plus can oxidize H2 to H plus and right. Next, zinc plus 2 can be reduced by H2. Now we will check zinc and H2 as well as silver and zinc also. Zinc and H2 and what is the standard reduction potential of zinc given? Minus 0.76 comma 0. So reduction potentials, if you observe, hydrogen reduction potential is more. Hydrogen undergoes reduction. So it is cathode. So reduction means it acts as oxidizing agent. So silver undergoes, zinc undergoes oxidation. So it acts as anode. So it acts as what? Itself participating in the oxidation means it acts as reducing agent. That means what is the reaction? Zn undergoes oxidation. Zn plus 2 electrons. Hydrogen undergoes what? Reduction. Reduction means what? Reduction reaction of hydrogen 2H plus 2 electrons. So it's to H2. This is the cell reaction. Zn plus 2H plus is raised to Zn plus 2 plus H2. Right. So zinc can oxidize H plus ions to H2 or H plus ions can reduce. Sorry. Zinc can reduce kadandi, reduce gain of electrons, reduce. Zinc itself participating in the oxidation, so zinc acts as reducing agent so zinc reducing agent, that means zinc can reduce H plus ions to H2 zinc is reducing agent. Hydrogen is what? Oxidizing agent. Oxidizing agent. Hydrogen is oxidizing agent, so itself participates in the reduction so that means H plus itself participates in the reduction, right? Here H plus is oxidizing or not? Oxidizing zinc. H plus can oxidize Zn to Zn plus 2 only. H plus itself participates in the reduction so it can oxidize zinc to Zn plus 2. But what is given and Zn plus 2 can be reduced by H2. Zn plus 2 can be reduced. Whether Zn plus 2 can be reduced or zinc is oxidized zinc is oxidized by H2. Okay, zinc is oxidized zinc itself and involved in which reaction? Oxidation reaction. But what is given in a reduction reaction is given for zinc. So that is not correct one. Not correct one. Okay. కొంచెం ఆలోచిస్తే ఈజీగా వస్తుందండి రైట్. నెక్స్ట్ ఇఫ్ యూ వెరిఫై సిల్వర్ అండ్ జింక్ అండి, సో మెనీ ఎగ్జాంపుల్స్ ఐ హ్యావ్ గివెన్ based on this 0.80 minus 0.76. So silver reduction potential is more, so it undergoes reduction. Okay, zinc undergoes oxidation. That means silver can act as reduction means oxidizing agent, zinc means reducing agent. So silver participates in the oxidation, reduction or oxidation, and silver participates in the reduction. Okay, that means itself acts as oxidizing agent. That means silver can reduce Zn plus 2 ions. Sorry, oxidizing agent. So that means silver can oxidize zinc to Zn plus 2 ions. Oxidizing agent. So therefore silver can oxidize Zn to Zn plus ions, but not reduce any. Okay. Option D is also not corrected. Otherwise, you write the reactions and then you will get more clarity. Ag plus electron gives rise to Ag. Zinc oxidation and Zn gives rise to Zn plus 2 plus 2 electrons and so net reaction is like this: Ag plus Zn. This is the spontaneous reaction and this is the spontaneous reaction occurs and okay. So here what happens and Ag plus can oxidize. Ag plus can oxidize. Ag plus can oxidize. Oxidizing agent kadandi. A silver is oxidizing agent. So itself participates in the reduction. Ag plus can oxidize zinc to Zn plus 2 and next what about silver and zinc? Zinc can reduce, right? Zinc can reduce Ag plus to Ag and zinc is what? Reducing agent. Zinc is reducing agent. It can reduce Ag plus to Ag and but what is given and reverse given and silver can reduce Zn plus 2 ions given, but zinc can reduce Ag plus ions spontaneously. So that is also not correct and the first one only correct. Right? Potassium chloride is used in salt bridge because in salt bridge, whatever the salt we are using, very, very important in this question, whatever the salt we are using, okay, that transport number of cation and anion must be same and transport number of cation and anion should be same to maintain electrical neutrality, to maintain accumulation of charge and to okay avoid excess potential development and to avoid excess potential development. Okay, so one is moving with the fastly, another one is moving slowly. Transport number depends on what? Speed of the ion. Transport number is directly proportional to speed of the ion. So one is moving fastly, another one is moving slowly. Then what happens? Charge separation occurs. Some excess potential is developed, and so we'll get errors, and that's why uh, we have to prepare salt bridge with a strong electrolyte where the transport number of cation and anion should be same. And so why we are using KCl and S? Both have same transport numbers or both have same speeds, same mobilities, same velocities. Okay, Nandi. Uh, Once a question given and in DL exam, AB is given. Okay, with different combinations given and transport numbers combination 0. 0.7, 0. 0.3, always some 1, right? 0. 0.6, 0. 0.4, 0. 0.9, 0. 0.1. Okay, next 0.5, 0.5 are nearly same and 0.49, 0.51. So in which case it is suitable for using in the salt bridge and in which case it is suitable and in this case it is suitable to use in the salt bridge since transport numbers of cation and anion is almost same like that different combinations given. Next one, in a cell that utilizes the reaction, addition of H2SO4 to cathode compartment will what happens and okay increases the cell potential, decreases next to shift equilibrium to left, shift equilibrium to right according to Lee-Chatelier principle. If you increase the concentration of H plus, okay, equilibrium shifts in the direction where H plus is consumed and that means equilibrium shifts in the forward direction, that means equilibrium shifts towards right and equilibrium shifts towards right forward direction or we can say that towards products and ఏ విధంగా అయినా ఇవ్వచ్చు towards products. Okay, once again we are increasing the concentration of H plus ions, then equilibrium shifts in the direction where H plus ions are consumed, that means forward direction or right or towards products and so to right that is correct and so option A and D are not correct. Now we have to check whether potential increases or decreases with H plus ion concentration. To check how potential changes with concentration we have to apply Nernst equation. So now apply Nernst equation. I am writing directly E is equal to E0 minus 0.06 by N. Number of electrons are involved 2. Anyhow, here N is not important. Log product side ions, concentration of Zn plus 2. Gas is given, but its pressure is not mentioned. Pressure is not mentioned means it may be 1 atmosphere by H plus power 2. This is important. And how electrode potential changes with H plus ion concentration. So E naught plus 0.03 log H plus power 2 by Zn plus 2. Okay, if you write reverse and minus becomes plus. So therefore from this H plus we are getting in the numerator and a positive sign we have. That means as concentration of H plus ion increases, what happens to cell potential also increases. Cell potential or electrode potential increases cell energy. Okay, one is anode, another one is cathode given. So as concentration of H plus ion increases, cell potential also increases and increases the cell potential. Option C is corrected. Next one, select the correct statement. In an electrolytic cell, cathode is negative terminal and anode is positive terminal. In cathode, in electrolytic cell, electrolysis and okay, cathode and anode. Cathode is connected to negative terminal of the battery, anode is connected to positive terminal of the battery. So here electrons enter into the electrolyte solution through cathode, and the electron is possess negative charge, electron rich, and as electron is as cathode is electron rich, cathode is indicated with negative sign, anode is indicated with the positive sign, and that's why cations move towards cathode, and cations move towards cathode, and takes electrons from cathode, and they undergo discharge. The charge is neutralized, and okay. So therefore cathode is electron rich, and electrons enters into the electrolytics this electrolyte solution through cathode, and okay. So cathode is negative terminal and anode is positive terminal. That is correct one, and that is correct one, and so this is wrong. Next, at equilibrium E0 cell is 0. At equilibrium, what we have on delta G is equal to NFE0 cell is equal to NFE0, NFE, sorry. Delta G naught is equal to minus NFE naught. Delta G is equal to minus NFE, and so at equilibrium E cell is 0 and not E0 cell. At equilibrium E cell is 0, not E0 cell, and under standard conditions we make it. But as long as standard conditions are not mentioned, E cell is equal to 0, not E0 cell. And next, in galvanic cell, what about cathode? Reverse we will get, and here cathode is negative, anode is positive. But in galvanic cell, cathode is positive terminal, anode is what? Negative terminal. Okay, we know that at anode oxidation reaction occurs. At anode oxidation reaction occurs. For example, zinc gives rise to Zn plus 2 electrons. So at anode electrons are released. So anode is electron rich, and anode is electron rich. So anode is indicated as negative terminal. Cathode attracts electrons, and so cathode is indicated as positive terminal. Okay, reverse we will get. Last one, the reduction potential of hydrogen cell will be negative if, when we may get reduction potential of hydrogen cell negative only. So if you write the reduction reaction of hydrogen electrode, H plus electron gives rise to half H2. You may take this one or this one, and both are same, and I told you electrode potential is an intensive property, and electrode potential is an intensive property, so you may calculate for this or this, you will get same, and okay. When we will get negative, and okay, E is equal to what? E0, H plus is changing to H2. That means we are calculating reduction potential minus 0.06 by n, number of moles of electrons involved 1. Log product side we have hydrogen gas, pressures are given, and so take pressures, and pressure also, pressure of hydrogen gas power 1 by 2 pi concentration of H plus. What is standard hydrogen electrode potential? 0. So that is equal to, if you convert minus to plus, 0.06. Here we will get reverse, and log concentration of H plus by pH2 power 1 by 2. So now we want to get what? Delta, cell potential negative, and when we will get E electrode potential negative, when we will get electrode potential negative, and when we will get negative, and if numerator is less than denominator, or H plus by partial pressure of H2 power 1 by 2 less than 1, and if that ratio is less than 1, we will get negative value or not. Log 1 is 0, log less than 1 is negative, we will get. So in each case check H plus by pH2 power 1 by 20. First option, H plus by pH2 power 1, 2 by 1 power 1 by 2, 1, and so 2 we are not getting less than 2. Second option, B, what? H plus, and H plus is 1, pH2 1, and 1 we are getting, and log 1 means 0 we will get, but not negative. Option 3, what we have? Concentration of H plus, that is 1 by partial pressure of H2 is 2, 2 power 1 by 2, 1 by 1.414. Numerator is less than denominator, and less than 1 we are getting. Okay, Nandi. This value we are getting less than 1, and log less than 1 means we will get negative 1. So in this case we will get negative 1. What about fourth one also? 2 by 2 power 1 by 20, 2 by 1.414, and we will get greater than 1, and positive we will get, right? So option C is correct, and so these are the some questions from Nernst equation, and based on Nernst equation, based on cell potential and electrode potential, and okay, thank you.